Hi everybody, this is Tor Storley and I am back with another video. In this video, we're going to take a look at how you can do fuzzy searches, how you can find misspelled words, testing two strings for similarity, and we can do that in DuckDB. DuckDB has several functions that you can perform this type of analysis. So in this video, we're going to take a look at those functions. We're going to break it down a little bit. I'm going to even show you some details how this is calculated. And then we're going to also show some examples of how you can use it and get some results and so forth. The whole thing is in a Quarto document. I used a mixture of things. I did research. I went to DuckDB's homepage. I studied up on these functions they have. I used AI to find some relevant examples. So this is the end result of what I came up with. Okay, so first let me show you my setup here. So I have this Positron open here. As you can see, I set a reference to the Python 3.12.3 version, and it's in this virtual environment. So you can just select your interpreter, like from this list here. If you want to be in R, you can do that. If you want to be in Python, you can do that. So it's set for this place where I have my packages installed. If you're not too familiar with the setup in Quarto, there's a source and there's a visual. So the source is the raw code. The visual is more what the output will look like. So I currently have it set for source. So that's why you see it like this. Now, I did go through this in my previous video, but for those who didn't see that video, let me just quickly lay out how this Quarto document works. There's a title, so you can have a subtitle and the author. You set up to a date, which is today. You can set up format. In my case, I'm making output to be HTML. I can set up a theme. Currently, I have it set for this superhero theme. And those are kind of bootstrapped themes you can find out on Quarto's theming pages. There's also a way for you to set up your own theme. You can have a table of content, yes. 3 levels deep, yes. You can code fold, which means you're hiding the code, but you're showing all the output. You can also do all kinds of manipulation here with echo off and so forth if you don't want to see the output. They show code, embed resources through, smooth scroll through. And then I have some CSS, as you can see, where I'm setting up some classes, similarity info, function highlight, and real world example, performance tip, etc. So those are CSS classes. And then I set up an execute, warnings false. I don't want to see any intermediate messages. You take that out here. And this caches through. That really helps you when you're going to make some changes to your document and then re-render it every time. Because you do this by this preview button up here, it will re-render it. Here I'm importing in the Python code section here. This is the setup version. So that's the first thing that runs when you set up this document. I set a reference to DuckDB, to pandas, to NumPy, and to great tables, as you can see here, different parts of it. I've been making some videos before about some of these, so take a look at those if you want more information about great tables, etc. And also I want the IPython display be imported, and warnings, and filter warnings ignore. So I don't want to see any warnings coming up with it because that goes into the output, and I don't want to see that in the output. And then I'm setting up a connection to DuckDB. So in other words, an in-memory database here, because there's no path, as you can see. Let me just quickly, without going too much into this document, you can see how I code cells, I write between it. The way Quarto lays it out is that this is the top level in a table of content, that becomes the second level. And if there's 3 of them, that becomes the third level, etc. So let me try to render this document now and see what it will look like. So right now it's set to this superhero. But what I want to do is, I want to use my own custom. So I'm going to take this guy out like this. And then I'm going to just use the custom. The only difference between the superhero and this one is the background color. In the superhero one is a dark blue. I changed it in this file to be green. So let me just render this and I'll show you behind the scene what that file looked like. So as you can see, it starts spinning up here. And you can read it down in the terminal below here. It will take a few seconds for it to run. It's starting the Python kernel, you can see here. and it's going to start building this document. Because I have a cache already, it can read from the cache and therefore render the document much faster. And now you can see here's this green background I was talking about. So in order to see this in the browser, you click this button up here like this. And so now you get it in the browser. So here I'm using this special SCSS background in this document. Now I happen to have that in my folder structure. So let me show you quickly what that looks like. That is this one here. That's the one it references, okay? So here is this cache we were talking about. And as you can see, it stores a bunch of stuff about it. So it doesn't have to go and reproduce it every time. It just grabs from this cache and when it renders this document. So that's one of the advantages because then it goes much quicker. Now, if you look here on the right-hand side, this is the TOC or the table of content. So here's the first level. Here is the second level, first level, and then you have second level, etc., etc. So you can go to this Quarto theming page here, as you can see. So here you can see some of the themes. So if you choose, say, Lux here, right, you click on it, you can see what it will look like based on nav bars and buttons, etc., like this. Another thing you can do is you can create custom themes, as you can see here, like this. And you create a file, basically, like I do, and you can set the reference to these different themes. So if you go here, they have already given you these files that you can use for custom themes. So the one I was showing you earlier is called Superhero. So when you click that guy and it opens up, you can see what it will look like in here. And for example, the only thing I changed was this piece right here. I changed the color to dark green instead of dark blue. So you can actually take this, you can use this one and just make some changes to whatever you want to make changes to. And then, of course, you can refer to it in, like I'm doing, in the theming section up here to that file like this. Another thing I can do too is there's some built-in themes that I showed you that are part of Quarto. And some of them are just plain vanilla. It's like 4 or 5 of them. So let me show you what they look like quick. So if you go here to the HTML theming, you can see these are the built-in ones, and then it has some boot watch themes of here. So there's a Cosmo theme, for example. That's kind of plain vanilla. So if I want to change my theme now, and if I'm inside my text here, so you can see this is the one I produced in the Positron, I can change this. So what I can say is instead of using the Superhero, I can say Cosmo, for example. And now when I preview this, it's going to run again, and it's going to change. It's going to read from the cache, and then it's going to reproduce this. So if you look here now, you can see what it looks like up here. And you can see it's rendering here, and then it's going to produce this new one. And now you can see this is the Cosmo theme. This is what that one looks like. So it's a little easier to read because it's just white background. So I'm going to use this one for demonstration. But if you don't like the look and feel of this theme, just try one of the others and you should be good to go. All right, so let's get started on this video tutorial. Okay, so what I'm going to do then is now that you know something about my Positron and how you rendering these Quarto pages. So as you can see, let me make it a little bigger like this. You can see here's the title, here's the author. And then I have this show code because that came from the Positron document where I said code fold, this one, right? True. You can see I can open and close it. So it's folded by definition here in the beginning. So what does this mean then? Well, you can see what we're trying to do is we're going to look at these different functions and measure how similar strings are, for example, and sentences. And also you can use it to do like a fuzzy search, spell checking, and data deduplication. So those are some of the things you can do with this stuff. Now, where do you find this stuff? Well, if you go to DuckDB, you can go to the SQL section here, go to functions like this, scroll down a little bit, and when you click on text functions, go to this text similarity function, and down here you can see here are the different functions you can use in DuckDB. And of course they do different things, and here they explain a little bit of what these functions are doing. All right, so as you can see, I list some overview of these functions here. So if you look at this, the first one here is Löwenstein. You have one word and the second word here, the S1, S2. There's a distance function. So the first 4 here you can see are distance functions. So this first one here measures the minimum single character edits. One thing you're going to notice is there's a difference between transition and inserts, deletions, and substitutions, because the way they calculate this is going to determine how many changes you need to make to get them similar, or to figure out the differences, so to speak. This is an extension of this, and it includes transposition. So they add this transposition to whatever this one is doing. Probably have one less step. If you were going to insert something, you might have to delete something first and then insert it. So as you can see, there's a hemming, and that's a distance, and that measures the character difference for equal length strings. So it's going to calculate the difference. Now, this will become a little more clearer once we start going into this. But then you're getting more into like sentences and similarity for words, etc. And you have this Jacquard function, and that one takes a value between 0 and 1. And then you have the Jaro similarity function, okay? And again, we'll look at some data. In this video here, we're going to look at the first few functions, and then we're going to pick up in the second video, because otherwise I think the video is going to be too long. So now we're getting into DuckDB. So let me show the code. And if you look at this code here, you can see and create a variable that's going to execute this code. I'm going to create this table if it doesn't exist in memory, and I'm going to select everything from these values. So there's apple with 2 P's and apple with 1 P here. So that's a common typo, as you can see. Here you have a misspelled letter, and etc., etc. You can read this on your own. So there's basically words here I'm going through. Netflix, Netflix, and so forth. What you do is you give them some column names like this, and then you convert it into a pandas data frame. And that's very, very easy to do, as you can see in DuckDB. You can simply do this .df, and it will convert it into a data frame, because we imported pandas above here, as you remember. All right, and then what I do is I create a second variable here. This is going to be for sentences. And all of these sentences are basic sentences. You've probably seen 100 times in examples before. You know, the quick brown fox jumps over the lazy dog, etc. And again, you just create another table, call it sentence data. And then this one was called demo data. And then what you do is you do the exact same thing. And then you just print out, hey, created successfully. And then you can see the output right here. Select original typo from demo data. This is just to verify that everything was put into that table. And then we're going to display it, okay, like this. So this is the table right now that sits in memory in DuckDB. And as you can see, there's the typo, missing a P. There is the original. All right, very good. Here is the same thing, but just for that sentence table. So these are the sentences in this table. And again, I'll make this available to you out on my GitHub repository so you can play around with it yourself. Now, we're getting into the distance-based functions. So Levenstein distance is the first one we want to look at. The minimum number of single character edits needed to transform one string into another. Remember, it didn't do the transition, but it did the insert, delete, and substitution, right? That's the Levenstein. So when you look at it here, then you can see that I'm querying the original and the typo, and then I'm running this function right here where I pass in string 1, which is the first word, and the second word. And I call it edit distance. This is this one here. So when you run this, you're going to see here how many changes took place. Remember, you don't do transition here. Well, in order for you to get this typo word to look like this, you need to insert 1 P right here. So that's one edit you need to do, okay? Google, same thing, one edit. So all of these others you can see, it's the same thing, whether you delete something or you insert something or substitute. You have Microsoft versus Microsoft. So what's the difference? Well, you can't do transition. So you can't just move this C in front of the R, right? Because you need to first delete one character and then insert another one. So what you have to do is you have to delete the R, that's 1. And then you have to add the R after the C to match this one. And that takes 2 changes according to this formula here. The Levenstein produced 2 changes, as you can see here. But the Damero Levenstein, this one, that one includes the transition. So it's a more efficient way of doing it. So that one removes a step because the only difference there was this R and C. So if you can use transition, you can simply switch the two. You can move the R behind the C and the C in front of the R type of thing. And you don't have to delete one and add one. So that Levenstein was 2. This one is 1 only because you just switched the two. This next one here is called Hamming's distance count. So what this required is that you have same number of characters you're comparing. So you can't have less than this one. So if you look at it here is this Hamming function, I should say, and you're passing in string 1 and string 2. You can just do a length function to figure out how many characters are in these words. And here is the words we can use. So what happens when we run this guy? Well, let's look. They both have the same length, 5 and 5 and 6 and 6, like this. So the Hamming distance here, the only difference here, for example, is that this one has an E and this one has an A. So it calculates one difference like this because of that one character. Words has 2 because why? Because they both have WOR starting here, but this one is not the same as LD, is not DS. So you can't just transpose it here, and therefore this one has 2 differences. This one has 1 difference between the 3 and the 4, so that's 1 difference. And here you have 1 difference between the 9 and the 8, so that's 1 difference. So where do you use this? Well, when you have fixed length, say you have product codes, for example, and they're they're same, but you want to measure and see if they're matching and not the same product code in some other system of yours, you can use this to detect errors for it, like for quality control and so forth. So you basically want to match the words. If you see any differences, there's something wrong in those codes, for example. Okay, so that is the distance-based functions. Next, we're going to get into the similarity-based functions, and that will be in part 2 of this video. Okay, I hope you like these videos, and if you do, please give me a like and consider subscribing to my channel. That'd be fantastic, and I shall see you in the next video. Have a great day, night, wherever you happen to be in the world.